Dragon estate agents have a rectangular sign on the outside wall of their office building. Okay, so here's the sign with its dimensions. So we can see it's 6.2 meters long, 4 meters in height. So it says then the manager, Leo, wants to make badges for all staff to wear. And these badges, it says Leo wants the badges to be similar to the sign. Okay, so the word similar there is bolded. And it says then the height of the badge is 2.4 centimeters. Okay, so by calculating the length of the badge, find the area of the badge. So we need the length. You can see here I've mocked up a sketch of the badge here, and we're told the height is 2.4 centimeters. We just need to know what that length is. Of course, we're going to compare it to this shape here, this sign, which is similar in size. In order though to compare, we need to have consistent units. So remember now, we want to change meters to centimeters, and of course we know that in a meter there's 100 centimeters. So if we've got 4 meters, okay, it's going to be 4 lots of 100, so that will be 400 centimeters. And similarly then, 6.2 meters will be 620 centimeters. Okay. So this shape here, the sign here, is much larger than the badge, and we can determine actually what the scale factor is. Okay, so we can do a length scale factor by comparing the heights. Okay, so we can do a simple division to see how many times larger this is compared to this. So we can do 400 shared by 2.4 to get our length scale factor. And if you work that out on a calculator, it comes out to be something like 166.6 recurring. But that's just saying then that the sign is 166.6 recurring times bigger, okay, than the badge. Okay, so we'd expect the same then for the actual length. Okay, so we'd expect this length here to be 166.6 recurring times this length here. So what we can do to work out the question mark, we can mock up a little equation. Okay, so the question mark there, and if you think about it, because we want to make this 166.6 recurring times bigger, we can multiply it by this. Okay, better off to leave it as the fraction actually, because you'll see why now this might help later on. So we're going to times by 400 divided by 2.4, and when you actually scale this up, when you times it by this scale factor, of course we're expecting it then to come to the length of the sign, which is 620. Okay, so we can just do a simple bit of math here to work out what length is, what question mark is. And if you think about it, we could, because we're dividing by 2.4 here, we could take that over the other side. So let me just write 620 first. Because I'm dividing by 2.4. When you take it over, you end up timesing. Okay, and then because we are timesing by the 400 on the top here, we can take that over and divide by 400. So what happens is that this length scale factor, fraction, just gets flipped, and you're timesing it then by the 620. So if I do that on my calculator, I will get my answer, and that comes out to be 3.72. Okay, so I know now my length, so then quite simply then I can do the area is length 3.72 times the height, which is 2.4, and I do that on my calculator and I get out the answer to be 8.928 centimeters squared for the area, okay, of this badge. Now, to keep things simple moving forwards, when we're looking at scale factor, okay, we're obviously comparing corresponding sides. Okay, so we compared the 400 there with the 2.4, and we had this scale factor here. What you can do is write down the alternative way of doing this, because this is saying how many times bigger this is compared to this. But if you wanted to look at how many times smaller this was compared to this, you could flip that fraction. So whenever we do scale factors, it is often helpful, okay, so that I'll write S after for scale factors, it's often helpful to write both down. So you could do 400 divided by 2.4 or 2.4 divided by 400, and then you can decide then on which one you're going to use. So in this case, because I needed to work out the length of the smaller shape, okay, I needed to correspond it to this side here. So I need to make this smaller. And if I need to make this smaller, I just times it by the smaller fraction, okay? In other words, the scale factor with the smaller number on top, because timesing it by this will then shrink this, reduce it down to the appropriate size, okay? Because this is telling us, of course, how many times this is smaller compared to that.